section of Chapter 3, Proportional and Non-Proportional Relationships. Nothing too fancy here. We've already kind of talked about both. Well, a proportional relationship is our direct variation, right? If it goes through the origin, or it's in the form y equals kx, like I show here, it is called proportional. The graph passes through the origin. Okay, so that's important. So all my proportional relationships, doesn't matter how they're going, they pass through the origin. They are proportional. So first things first, let's use a problem where I have a proportional relationship. This table shows the number of miles driven for each hour of driving. Write an equation to describe this relationship and predict the number of miles driven in 8 hours of driving. Well, I know it's proportional because at 0 hours of driving, I haven't driven any miles. So I know that it's going through the origin. So I'm going to use my y equals kx form. And if I take a look, hours would be my x, right? The more hours I go, I move up in miles. So miles would be my y. So I could solve for k using any situation. I'll just grab my first guy here. So I got 50 for y, k for x times 1. Well, that's kind of my slope, isn't it? When I divide by 1 here on both sides, k is 50. I could have figured that out just by graphing it. So 50x, there's my equation. So if I would have started graphing this, I'll count by, I'm going to skip ahead. I'm going to count by ones, but I'll skip every other here. And then here, let's count by, let's go by 20s. So 20, 40, 60, 80, 100, 120, 140, 160, 180. And let's graph these. So I got 150. And I got 2 100, and I got 3 150, and 4 200. So it's going through the origin. It should make a line, okay, because these are all linear. And then it says estimate 8 hours of driving. Well, hours is in for my x, so I'm going to plug in 8 for my x here. So 50 times 8, and we end up with 400 miles. That would be my answer. So I wrote the equation, and I described the relationship with that y equals 50x, and then I predicted by plugging in 8. It didn't tell me I had to graph, but I wanted a graph to give this guy a visual. So there's an example of a proportional relationship. Goes to the origin. Let's deal with the non-proportional and see what this looks like. See if we can come up with an equation. Write an equation in function notation. Well, function notation just means I'm replacing f of x in for y, if you remember doing that. So instead of using like y equals mx plus b, I'm going to say f of x equals mx plus b if I write my equation of a line. For this graph. So let's go ahead and let's graph these. So 1, 3, 2, 2, 3, 1, 4, 0. I'm going to graph that in. Well, it's a straight line, so can't I use my equation of a line right here to come up with an equation, or equation in function notation? But like I said, instead of using a y, we're going to use f of x equals mx plus b to make it in function notation. Well, what do I know about this line? Do I know its slope? Sure, I can find that. I can just count from any point to another point. Let's use these 2 points. I'm going down 1, right 1. So down 1, right 1, right? Rise over run. So it's really a negative 1 in for m. And I could find that of subtracting, right? 2 minus 3 is negative 1. 2 minus 1 is 1. Rise over run. Okay, either way. In my y-intercept, well, I have it right here, don't I? It's at 4, 0. It's at 0, 4. So I know my y-intercept is 4. So let's simplify my equation up here. I don't need to write that negative 1. It's just a negative x plus 4. So here's my equation in function notation. And this would be non-proportional because why? It does not go through the origin. My graph does not go through the origin, so it's non-proportional. And really, I'm just using the slope-intercept form instead, which I kind of did in this first one, except there is no y-intercept because it goes through the origin. So what do we notice the difference between these two? Proportional there is no y-intercept, right? There is no plus b. And instead of using m for slope, we just use k for the direct variation, the constant of variation. And that's the only difference. They're really kind of the same thing. One passes through the origin, the other one does not. That's all there is to it. So if I'm going to write an equation in function notation, I just use that. So in this case, my first one, this guy's proportional. I don't need to write that. But that means I'm going to use y equals kx. My second one over here, this one's non-proportional because it does not go through the origin, which means I'm going to use y equals mx plus b. And it says write it in function notation, so I'm going to be using f of x instead of y. Okay, so I'm replacing y with f of x. So let's look at my first situation. So I'm going to say f of x equals, well, the k, isn't that just my slope? So if I go from one point to another, I went up 2, right 1, up 2, right 1, rise over run, x, and then simplify that. Oops, what am I doing? That's an x. Equals 2x. Done. That's all you got to do. Just plug in your slope, and then if it's non-proportional, like in this second case, plug in the y-intercept. So here, I'm replacing y with f of x. Can I find the slope? Well, one point to the other went up 1, 2, 3, 4, 5, 6. It went up 6. It went right 1, 2. And then it has a y-intercept at, well, I can tell, right? It shows it. It crosses right here at -2. And let's simplify this. So f of x equals 3x minus 2. Done. There you go. So if it's proportional, it goes to the origin. Y equals kx. There's just no y-intercept. Just find its slope. If it's non-proportional, it does not go through the origin. So you need to find the slope and the y-intercept. And for function notation, just use f of x. Okay, not too many. Shouldn't take you too long.